My name is Todd Green. I'm the CEO of PubNub, and I want to talk to you today about microservices in the network. To use Sun Microsystems' old adage, the network is the computer. We'll talk about that in a second, but first I'll show a quick video. Things have in common. All those applications we just saw, social applications, drones, games, those are all examples of real-time applications. Real-time applications are growing in popularity across almost every industry and software there is today. And today I'm going to talk about what we've done as PubNub in terms of connecting real-time applications and how we're launching a product to allow people to start building real-time applications a lot more easily. So first of all, let's talk about what a real-time application is. Let me define that. As I mentioned, across all these different industries, we see real-time applications. We've seen Periscope, we've seen Life 360, a lot of social games like Pocket Gems, allowing people to interact in real time. Move into IoT and smart home. Now I expect when I hit a button on my phone, no matter what network I'm on, it's going to turn a light on, whether I'm across the room or half a world away. Uber and all of Uber's competitors, Get, Lyft, Easy Taxi, Delphi, there's so many of these companies, and Uber's for everything. They're all real-time applications. They're tracking the locations of taxis or other things in real time, showing a subset of that information to the end user, and allowing streams of information to pass between cars, people, and servers. Financial applications. We've seen real-time stock quotes for a long time, but now you see companies like SAP announcing that the new user interface for all their business applications is going to be real-time. Real-time charts, real-time graphs, real-time inventory information. Online collaboration. eBay is doing things like real-time chat now between buyers and sellers. Autodesk takes a whole wide view of real-time, from notifying the user based on what's happening on the server to allowing for rotations of objects in 3D across the world so everyone can see those objects rotate at the same time. And just another example, audience participation. More and more brands are creating experiences online that allow people to collaborate, to chat, to play games around a specific social event. So across so many different industries, we're seeing real-time. And architecturally, from a software perspective, what's the difference? What actually changes? Well, for the last 25 years, actually, let me back up and talk about the emergence of the streaming web, then I'll talk about the architecture. So we've seen the architecture emerge for the web over the last 25 years, and then in the last 10 years for mobile. But the streaming web is about to overshadow all of that, because not only are a lot of websites and mobile apps turning into streaming applications, but there's this advent of IoT. So we're moving from this year, 2016, where there's an expectation of 2 billion smartphones in the wild, to an expectation by Cisco that 4 years from now there's 20 billion connected devices, all streaming data back and forth. So back to my earlier point, architecturally, who cares? What's the difference? We've been building applications on a REST-based approach for a long time. Request, response. Send a request to a server, wait, get back a response. And that's worked well. It's scaled. We know how to build huge REST-based applications for website, for mobile apps, and so on. Streaming applications look different. Streaming applications are devices that are constantly streaming, emitting data, consuming data, tiny packets of data. It could be temperature readings, it could be social data, it could be financial data. And so PubNub and other companies over the last 5 years have evolved to, in the case of PubNub, offering a service that we call a data stream network. And that can basically really make that last mile of connectivity easier, keeping a connection open to allow small messages going back and forth using a publish-subscribe interface so that any of these applications can be built easily. Because one of the biggest pain points of real time is keeping a socket connection open to these devices, publishing and subscribing at global scale. And so the way we think of PubNub is it's kind of like a content delivery network for real-time data. Now, this has worked really well, and by almost every measure, PubNub has grown amazingly well over the last 4 years, and it's been a pretty successful venture. But real-time applications don't really look like this. This is just the devices sending and receiving the data. But in reality, where does the business logic go? In almost all of our customers' use cases, they want to put the business logic somewhere between the publisher of that data, that message, and the subscriber. And so what we really see are real-time applications looking like this, where devices are publishing data through our network or a network similar to ours, then receiving it on their servers, doing some calculation, turning around, and publishing that data back. In essence, we're using three-tier architecture. What we've always done last generation's technology and infrastructure to solve this generation's problems. And just like the previous speaker, talking about monolithic to a distributed model with microservices, we need to do the same thing in real time, except these real-time, low-latency applications have added challenges. When you try to use this three-tier architecture, you're driving up cost. There's all this ops complexity dealing with sockets and streaming around servers. You add a lot of latency, reliability, and some interesting security challenges as well. Let me illustrate this with kind of a silly example. Imagine there's a cola company called Yummy Cola, and they're going to launch a big social application for the 2016 Soda Bowl. It's going to be a real-time chat, and they want to make it authentic. They want to make sure that millions of consumers can get online and chat, and they don't even care if they use bad language because they want to make this authentic. But there's one thing that Yummy Cola doesn't want. Their worst competitor, Gunk Soda. They don't want anyone to mention Gunk in the application. And oh, by the way, they also want to do some analytics to know how many people are chatting and when those chat messages surge up and everything else. So just because they want to do a simple substring removal and maybe do some analytics, what does their application look like? It looks like this. As these guys take these data streams from people chatting down to their server, and as more and more devices come online, more and more servers are deployed, they end up having a very, very large deployment for a reasonably simple if statement and maybe a few other sort of data storage elements. And they're also adding latency, adding a lot of complexity. Now, this isn't just a problem for someone building a social app for a mythical Super Bowl. It's the exact same problem we have when we're looking at taxi applications, when we're taking a look at how do we give me a subset of all the locations near me. If there's 1 million people looking for a subset of 1 million streams, it becomes a massive problem. Or running a rules engine for real-time data coming in from IoT devices based on average temperatures, or maybe turning a light on based on a garage door opening up. Or sentiment analysis, as you have lots of people voting or expressing their sentiment during some kind of social event, being able to measure that. And the same challenges happen during game development, especially now in multiplayer social games, where you want to make sure there's no ability to cheat, where you're doing game logic in the server, but you still want to keep that massively multiplayer application. I mean, think about it now. 2 billion smartphones in the world. Not all of us can invest in the infrastructure that World of Warcraft built for massively multiplayer games, but you can have a hit game like Pokemon Go, and all of a sudden have tens or hundreds of millions of people on top of an infrastructure. So, these are the kinds of problems we see our customers running into, and things that we've been trying to solve. And so we asked ourselves, is it possible to make our network into a computer? Can we remove those servers and push them up into the network so that we can create a programmable network? So over the last 3 years, we've been working pretty hard on this problem. And finally this week, despite wearing a t-shirt, barely got out of bed this morning, we are announcing PubNub Blocks. Now, PubNub Blocks is our solution for how to build real-time applications using microservices, but in a way that's easy, in a way that actually gets you to market quickly. And how do we do this? So we've got a global network today. Today we've operated pretty big scale. We have over 300 million devices on our network. We process over 1 billion transactions per month, 1 trillion transactions a month through our network, at pretty big scale. And so what we wanted to do is allow developers to drop JavaScript right on the edge in every one of our data centers, every one of our points of presence. So when they hit a button, they can deploy logic that gets processed at the edge as a message comes published into our network. We wanted to do this under low latency so that we can route that message to a piece of code that you've deployed in less than 10 milliseconds. We want the system to auto-scale and auto-deploy. So if you actually have more traffic, you can have more of these little blocks, we call them, that are running. Less traffic or more scale, it can auto-scale. One of the things that we do at PubNub is no downtime upgrade. So as we upgrade our network, we don't want to provide downtime. And we wanted to offer the same benefits to our customers. We want to let them push code into our network without having downtime. Replicated logic and storage globally. So these real-time applications aren't stateless, right? So it means that if you're storing intermediary values, like keeping a count of something, or a leaderboard, or the number or an average temperature from IoT devices, that data needs to be not only stored, but replicated. So no matter where in the world it's ingested, any one of those points of presence, that information can get additively calculated. We wanted to offer the same uptime that we do in our core network, which is, how do we deploy an infrastructure based on microservices that offers 5 nines uptime? What does 5 nines really mean? That means we can't be down for more than 26 seconds a month. So that really means no downtime, because it's very hard to react to anything that quickly. And we wanted to provide a lot of layers of encryption, AES being one of them, in our network to support this kind of infrastructure. So really the idea is a simplified kind of one-button click deploy of an auto-scaled microservices environment for low-latency applications. So this is what we've been working on for a long time. Let me show you how it works. Let's go back to that Yummy Cola example. So in the Yummy Cola example, it's really one line of code to strip out, if anyone knows JavaScript, it's looking for a gunk, lowercase or uppercase, case insensitive, replacing it with the word yummy, and really rewriting that chat message. So that's all you have to do in PubNub blocks. Write that line of code and click the deploy button. Now what actually happens, watch this animation. The deploy actually takes that piece of code, activates it, and then deploys it into all of different points of presence around the world. We have over, I think, 16 points of presence now on 4 continents. And as messages are ingested on those channels of data, in any one of those data centers, any one of those points of presence, that block is activated, and that information is processed. Now, no downtime upgrades is absolutely important here. So if someone makes a change to their code, data streams are coming through, there may be thousands of messages a second coming through. How do we deal with that? Well, like you'd expect, except it's all through a single button click. If you deploy a new version of your block, we activate it, then we spin traffic off of the old microservice and onto the new one, and then we move the block back as the primary block. So with no downtime, we can actually take streams of data and then move it off of the old version and onto the new version synchronously across all the data centers we have, all the points of presence globally. And again, the whole idea here is really to let our customers focus on their applications. So a lot of the things that were discussed in the previous, for those of you who watched the NGINX presentation on microservices, a lot of those concepts we wanted to implement. We wanted to do it in a way that was easy to build applications. So you're not thinking about the infrastructure of the microservices, but being able to deploy them into our network. How do we do data? Same thing. We've created a replicated key value store, kind of a simple DB type of database. That sits, and there's instances of them that sit next to each one of our block instances worldwide. And so by writing a line of JavaScript like this, which takes a counter you set, in this case called vote, and increment by 1, what happens? Well, it updates the local version, then it immediately replicates to all the other versions. And so within a second or so, all your data globally, back to the conversation we just heard around eventual consistency and optimistic writing, automatically happens in our KV store. So 2 lines of code, we're counting things, we're editing strings coming through. Again, we focus this on developers. We started with JavaScript as a language because it's pretty ubiquitously understood, it's pretty powerful, and can do some interesting things. We support real-time logging and debugging tools so you can see what's happening within the network. We have a beautiful user interface for doing this kind of prototyping, but we also provide CLI tools, so command line tools, for being able to integrate this type of approach into your continuous deployment process or any sort of automated deployment processes you have. We know that infrastructure is cool. We sell it. It's what we've been doing for 5 years. But we also know there's more people in the world who want to start with something. They don't want to just start with a blank screen. And so we launched PubNub blocks with this thing called the Blocks Catalog. And the Blocks Catalog is a set of pre-built blocks across a lot of different industries, IoT applications, social applications, geofencing applications. And these are pre-built applications running in our network. And all you have to do is click a try it now or a clone button. It'll take a copy of that code, put it into your account. It's all open source. And so it allows you to start with a building block, really a completely deployed application that you can take, modify, and use in your own application. So not only do these blocks do code that we've written, but many of them call out to third-party services. So if you think about real-time applications, or really any deployed application today, you want to leverage lots and lots of other APIs. Now you can call any API with PubNub in the middle of a block, but out of the box we have pre-built event handlers, pre-built blocks, with all of these vendors here. IBM Watson, RingCentral for SMS messages, SendGrid for email, SiteEngine for taking a look at images that are inappropriate and stripping them out. A whole set of these things. I wanted to show you just a couple of screen caps of some of these blocks operating because they're kind of cool. One of them, first of all, is one that takes just a raw stream of data from one or more IoT devices and automatically calculates mean, median, MAD, and also shows you, through an open source graphing engine we provide, the visualization of that data. So it was pretty cool. Before we had blocks, we had this demo and it was one line, and we were showing people how you could take data streaming through a network and you could graph it. That was pretty cool. Now you flip on this block, and you start seeing exception handling, you start seeing plot outliers, you start seeing all this really cool information that all gets calculated at the edge of the network. Another good example is a hangman game. Now, this is a pretty simple game, but what's neat about this is all the security and all the game logic happens inside the network. It's really a programmable network. And what's neat about this is if you look at the way a lot of people are building social games today, because they don't want to deploy huge numbers of servers, they're usually identifying a single iPad or a single iPhone of one of the end users and saying, you're randomly the game server. And then all the tie-breaking and logic for the game happens on one person's device, which is really not great because if that person goes in a tunnel, loses their connection, all the game players are done. Now you can leverage all of that network in all that logic in a scalable network. So if you build the next Pokemon Go, you're not sitting there thinking about how you're going to scale a secure game that works. Another great example here is using IBM Watson as building a chatbot that translates. This is literally just a few lines of code now. Every message that comes in makes a third-party call to IBM Watson, translates it into French and English, brings it back, republishes those on 2 different channels. It's pretty exciting for us because, as I mentioned, we've been around for 5 years. We've helped thousands of companies now connect real-time applications, and that's gone pretty well for us. But we see these challenges that our customers have over and over again in terms of where they put the business logic for their applications. And so by giving them sort of a very easy to deploy microservices-based network, it's a pretty nice extension, a pretty nice way of letting people build real-time applications. We got a lot of traction when we pre-announced this. We had over 900 companies sign up for early access. It's now in full production. You can sign up today. You can write a block for free. It's all available, all the documentation. Literally, just go to the website, sign up, and play with it. We announced yesterday an investment from Cisco and Ericsson. One of the things that I like to say, I don't think they like to hear this, but if you look at all the innovation over the last 20 years and all the infrastructure, everything from new kinds of web servers like Nginx, new kind of NoSQL databases, new kinds of CDNs that are out there, the one thing that really hasn't changed is the network. We're still dealing with TCP packets, we're still dealing with HTTP, and the general network really hasn't changed much. So this idea of really plugging microservices into a network, it's what Cisco calls fog computing, is really, I think, a new approach to thinking about the network in general, where you want to leverage it, and how you can make it programmable. So again, I talked about this already. We've hit some pretty big scale as a company that connects real-time applications. And we're already seeing pretty big adoption. We announced this, we launched it yesterday. I just saw an email before I got on stage. There's now, I think, 350 companies have already created and launched a block. So it's pretty exciting for us because we worked really hard on this over the last few years. But I would basically advise anyone that wants to learn more. We've got a booth over here. Or if you don't like to talk to people and you like to just go online, PubNub.com/blogs is a good way to try it out. Again, we really focus on making things easy to use, and so you don't have to pay us any money to play with it. You don't have to call anyone up. You can literally go right to PubNub.com/blogs, sign up, and play around with some of the pre-built blocks or build your own. Again, if you're interested in microservices and if you're interested in distributed real-time computing, this is a great way to get started. So thank you very much. I really appreciate it.